Okay, so for IM2, here's our final review portion on special right triangles. Now, special right triangles, we have two kinds. We have 45, 45, 90 triangles, and we also have 30, 60, 90 triangles. Now, in a 45, 45, 90 triangle, we have x on one side, x on the other side. Those would be your two legs, and then the hypotenuse is going to be x radical 2. In a 30, 60, 90 triangle, we have x for the shorter leg, x radical 3 for the longer leg, and 2x for the hypotenuse. Oops, that should be two dots there for a colon. Okay, so let's get started. We have a 45, 45, 90 triangle, which means that one of the legs is 4 radical 2. That means the other leg is also 4 radical 2. Okay, it does say leave our answers as radicals in simplest form. Now, the way I get to the hypotenuse is I take one of the legs and multiply it by radical 2. So 4 radical 2 times radical 2 gives me 4 radical 4, which is 4 times 2. And that means that side x, or the hypotenuse, is 8 for this problem. Okay, I'm going to go through and find all my 45, 45, 90s. Here's another 45, 45, 90. So the other leg v is also radical 3 over 3. That's part of my answer. To get the hypotenuse, I take radical 3 over 3 and I multiply it by radical 2. So that gives me radical 6 over 3. Can I draw a tree for 6? Well, I can draw a tree, but nothing's going to come out. So I just know that side u, or the hypotenuse, is radical 6 over 3. Okay? So again, looking for 45, 45, 90s. Here we go. Y is the other leg, so it's also 5 radical 2. And to find the hypotenuse, I take 5 radical 2, and I multiply by radical 2. That gives me 5 radical 4, and radical 4 is just 2. So that tells me that side x is 10 in that case. Another 45, 45, 90. Now this time they give me the hypotenuse. So the hypotenuse is equal to the leg times radical 2. So I actually have to divide by radical 2 in order to get what the leg is. Now, 3 radical 3 over radical 2, no big deal except that we can't have a radical on the bottom. So 3 radical 3 over radical 2, I need to multiply that by radical 2 over radical 2, and that gives me outside times outside is 3, inside times inside is radical 6. On the bottom, inside times inside is 4, and radical 4 just ends up being 2. Now, I can't simplify the 3 and the 2. I can't simplify 6 and 2 because I can't simplify inside a radical with outside a radical. And I know that 6 can't be broken down because I already tried that over there. So what did I just find? I found both u and v, because their legs, they're going to be the same length, is equal to 3 radical 6 over 2. And that's my answer there for both of those legs. All right, here's another 45, 45, 90. There's one leg. B is the other leg. That's also going to be 2 radical 3. A is going to be 2 radical 3 times radical 2, which gives me 2 radical 6. All right, another 45, 45, 90. Y is also 7 because it's the other leg. X will be 7 radical 2. Okay, I think we're down to the last two. I think 12 and 14 are our last two. So this side is 2. V will also be 2 because it's the other leg. And U will be 2 times radical 2. And down here, again, they give me the hypotenuse, so I have to do the same thing that I did up in number 8. So x times radical 2 will equal that hypotenuse. So to get the legs, I need to divide by radical 2. And I can't leave that radical on the bottom. So I multiply by radical 2 over radical 2. And that gives me 6 radical 2 over radical 4, which is 6 radical 2 over 2. Now that can be simplified because the 6 and the 2 can be reduced. That becomes a 3, that becomes a 1. So I have 3 radical 2 over 1, but I don't need to put the over 1. And that's going to be both legs, so x and y are both 3 radical 2. So there's all my 45, 45, 90s. Let's go back to 30, 60, 90. The easiest 30, 60, 90 problems are the ones where they give me the short leg first. When they give me the short leg first, like here, all I need to do is multiply that by 2 to get the hypotenuse. Short leg, I multiply it by 2 to get the hypotenuse. So 2 times that would be 4 radical 3. To get the long leg, I take 2 radical 3 and multiply it by radical 3. That gives me 2 radical 9. Radical 9 is just 3, so side y is 6. Okay. Number 4. This is the second easiest type. Actually, let's go over to number 3. This is actually the hardest type, so let's actually start at number 4. We'll do the second easiest type, and then we'll do the hardest type. Second easiest is when they give you the hypotenuse first, because to get from the hypotenuse to the short leg is always opposite your 30-degree angle, you just cut it in half. So what's half of 4 radical 3 over 3? Well, I just cut that in half. So y is 2 radical 3 over 3. And now that I have the short leg, I can just take that short leg and multiply it by radical 3 over 1, and that will get me the long leg. So 2 radical 3 times radical 3 is 2 radical 9 over 3, which is 2 times 3 over 3, 6 over 3, which is 2. So side x ends up just being 2. Okay? All right, number 3. This is the hardest one. Actually, it's not the hardest one. Number 7. They're giving me the hypotenuse. I guess it's the same as this one. To get the short leg, I cut the hypotenuse in half. So y is my short leg. How do I cut 7 in half? I call it 7 over 2. That's cutting it in half. Now, when they say simplest radical form in the directions, they mean they don't want any decimals. So please call that 7 over 2, not 3.5. So if that's my short leg, the long leg, x, is just 7 times radical 3 over 2, because again, we just multiply by radical 3 to get that long leg. All right, 4, 5, 6. All right, hypotenuse is 10. That tells me the short leg is half of that. And the long leg is the short leg times radical 3. Okay, let's see. 7's done, 8's done, got to do 9. All right, they give me the long leg. This is the hardest type of problem. When they give me the long leg, I have to go backwards to find the short leg. So I know that the long leg is equal to the short leg times radical 3. So to find the short leg, I have to divide by radical 3. Now I have that same issue with the radical on the bottom. So I'm going to have to multiply by radical 3 over radical 3 to get that off the denominator. That gives me 4 radical 3 over 3, because it's radical 9 and that becomes 3. That can't be simplified, so that's what my y value is. It's 4 radical 3 over 3. Then to find the hypotenuse, I just multiply this times 2. Now I think this is actually, is this just like when we did? Oh, close. We had 4 radical 3 over 3 up here. So if I need to multiply that by 2, think about it, times 2 over 1, that's going to give me 8 radical 3 over 3 as my x value. Okay, 10, 11, 12, we're down to 13 and 15, our last two problems. So they gave me the hypotenuse. How do I find the short leg? I cut it in half. So that means that y is going to be half of this. That's going to be 5 radical 6 over 2. And nothing about that simplifies. It's just ugly like that. Now that I have the short leg, I'm going to take it and I'm going to multiply it by radical 3 to find the long leg. That gives me 5 radical 18 over 2. Let's look at 18 for a minute. Can 18 draw a tree? 9 and 2, 3 and 3. It can, because we have some pairs, so the 3 has to come out. So I have a 5 outside. I'm taking another 3 out. We're taking a 3 out and leaving a 2 inside. So that gives me 5 times 3 is 15 radical 2 over 2. And that is what? My long leg? That's my x value. So that problem's crowding out the number 15, isn't it? Thankfully, number 15 is an easy one. So, let's see. Number 15, they give me the long leg, but thankfully the long leg is already in that radical 3 form. So, that means the short leg, I just take off the radical 3. That's the same thing as dividing by radical 3. If I divide that by radical 3, the radical 3's would cancel. Once I have the short leg, I just multiply it by 2 to get the hypotenuse. So my hypotenuse is 12. So there's your final review for special right triangles. So if you need to look at it, I kind of divided it there if you want to take a screenshot of that so that you can actually see what work goes with what problem. Maybe on the next one I'll try and use different colors so that you can see what work goes with what problem. So there you go, special right triangles. Happy studying.